We have a MacBook Pro. It's 16 inches, A2141. This is 2019. There was only one version of this, um, and then it was discontinued, and it was refreshed for the M1 16 inches. So this was the only 16 inches Intel that Apple made, and this one is coming in for no power. So as usual, we are gonna have a look at inside the device to understand why it doesn't start. We are not going to plug power to it because we're not sure of what state the device is in. You see? Okay. Which one? I put on there. Okay. The device look a bit clean inside, which is a good thing. So usually when the device is clean, it suggests that the device has not been tampered, which is a good thing. So, okay, the back screws are out. The next thing we are going to do is to identify the battery and then disconnect battery from the board. So for this design, it has two battery management. It has the battery data, which is the BMU battery, the BMU cable. So with that disconnected, I have effectively disconnected power from the battery onto the board. Now there are two battery power system designed for this board. You have the data line and the main battery line. Now this you will have very low voltage, and that is where you have a very high voltage. And then just a quick thing, please note that the PP bus that we always talk about, um, the battery do not require U7000 to create PP bus. Now U7000 basically, so as you know, U7000 will take a high voltage, and then it will convert it into PP bus, and then you get 12.6. By default, your battery uh, do not require PP bus to be regenerated from it. Your battery will supply PP bus voltage on its own. Do you understand? Unlike with the charger, for example, you have 20 volt, which then needs to be stepped down to 12.6 volt for PP bus. But battery by default itself holds the PP bus voltage. So the battery does not, you do not need an additional circuitry to allow you to generate PP bus for the battery. Okay, so that is that. Once the battery is out, and then it's also, I usually will mention that this alone is enough, but if you are not sure of the origin of the battery, then you can as well disconnect the main battery power line. Ideally, just the cable should be enough. But if you're not sure, the reason why I'm saying if you're not sure is if this is not a genuine Apple battery, chances are that even with the cable disconnected, because the battery is not properly configured, even with the cable disconnected, you still have active power from the battery to the board. So in that case, if you're not sure, the best thing will be for you to disconnect the main battery line. And then with that done, then there is no room for doubt. Okay, we need a T5 for that. Okay, and then another thing I also want to mention, you see with the 16 inches, the battery screw, it's longer compared to the 13 inches. So the 13 and the 15 inches, we use a short, so yeah, so the difference. So this is going to be for 13 inches and 15 inches, while this is unique to 16 inches. And by the way, that is unique to this design alone, because the M1 16 inches, they fell back to this design. So the M1 16 inches, they fell back to the regular size, but the A2141 is the only one that will have this battery, this screw for its battery. Okay, so that's so the next we want to do now is as you know, the first we want to see what if we have a short on our PP bus. And the reason why we always worry about our a short to our PP bus is because our CPU is controlled by the voltage that comes from PP bus. So let's go to the board view of this. So this is going to be an 820.01700. Let's see if we have it on previously open boards. 01. Aha, so there you go. 80-01700. Now the reason why oftentimes we worry about a short on PP bus is because our CPU and GPU, you are expecting to have a very low dropout voltage to our CPU and GPU. Now, these MOSFETs are going to take a high voltage and then turn it into a low one. So, if, for example, and not just that, so for example, on the output of your on the inductors here, you get the voltage that you get. It's very minimal. Whereas the voltage that comes into it, you see where it says PP bus voltage, that is 12.6 volt. Now, if one of these fails, for example, it will not be okay for this because what this is supposed to do is to switch on and off until it evens out the required voltage for your CPU vehicle, which is the voltage that will power your CPU. However, when that fails, it can choose to stay on at all time. Now, when it stays on at all time, the supply becomes constant. Remember, if for example, let's say, if for example, this the MOSFET fails. Okay, so okay, so if the MOSFET fails, the input, which is the PP bus voltage, is going to stay constant. It's still going in. Now, instead of the ideal thing for the three MOSFETs to do would be to do the switching on and off. But and then only when the process is it's properly completed, only then will it give an output. But if it fails, what happens is whatever it gets, it sends it out. And then when that happens, is you will obviously damage your CPU, and not just your CPU. Another concern is also the NAND chip. So the NAND chip is also powered by a buck converter, which is U9080. It takes a high voltage and then also step it down to a low voltage. So you see on pin 1 you have PP bus. Now the output of that is 2.5 volt. Now PP bus is 12.6 volt and that gets steps down to 2.5 volt. If this chip fails, the same thing will happen. Instead of it to output 2.5 volt, it will send out 12.6 volt in place of 2.5 volt, which will damage the NAND chip. It can be repaired, but what then happens is the client will have to lose their data. Now, the one way you can prevent that, it's by making sure that there is no supply of PP bus voltage onto the chip itself. And the way you can do so is by making sure that you don't have power onto the board. So if you connect power to the board blindly without having to understand what state the board is in, these are some of the chances, these are some of the damages that could occur. Another thing also is, for example, if the device is liquid damage, if you have active liquid on the device, it is very susceptible in that case to a short. It's very susceptible for the components to get shorted out. While it's in that state, it is not advised to connect power to the board without having to know what state the board is in. So that is just that about that. So now let us check and see if we have a short on our PP bus line before we connect power to it. So PP bus is we can measure PP bus on F7000 and F7001. So these two guys, we can measure our PP bus there, and those are the guys here. So these two guys here, those are sitting on our PP bus rail. So what you want to do is you want to use the loud guy. So we are going to use this one here because it's quite loud. And for you want to have the multimeter in continuity mode. And with this one, I did show you guys how your continuity sign will look like. So that it's your continuity sign, you see that. And if I switch it, that will be diode. So So right now, this is set to continuity. We're not going to use this for now. And one of the ways you can confirm that is when you join the probes together, you should hear a beep. And then another thing I also mentioned, I said you have to be attentive. Sometimes you might measure a circuitry and then you hear a beep. That does not mean that it is short. You have a short on that line. It may just mean it may just for example, if you're measuring along your CPU line, now, it may not just mean that you have a short. And then other times, you may measure and you don't hear a beep. That doesn't mean you don't have a short on the line. You always have to look at the figures that you get on your multimeter. Okay, so for that's for us to check for short, we have to place our black probe on ground. We can use that as our ground. We can use a screw hole as our ground, and then our red probe is going to be our guide. So let's we can use either of the fuse. Now that it's a dead short to ground. That's a complete short to ground. So what that means is it means that these two fuses, this rail here is completely connected to ground like that. Do you understand? So I'm just gonna get another board to show you. This is a fully functional board we use for testing. Uh, so I'm just gonna okay. The battery is already disconnected. Traditionally, I do not disconnect my battery cables from the right. I do it from the left. So if you see that, then that's not me, that's someone else, because I do it from that side. Nonetheless, so this is what you're supposed to expect from a working board like this. That's what you're supposed to expect from a working board. And for accuracy purposes, you want to maybe use your diode mode. So diode mode measurement, see what you have. Red probe. By the way, so you see now the difference now. It's when it comes to continuity measurement, you use your black probe on ground and then red probe. But with diode mode, the red has to be on ground and then a black probe. Otherwise, you get funny figures. So red, you see that 0420, and if we are to check this guy here, 0.014. And then another way also, diode mode measurement also, sometimes you may have very close readings that you're not 100% sure. That is where it's okay to have a fully functional board to compare the readings, especially if you're measuring on a data line, because data line sometimes they are very close, and and a very small figure might be the reason why your device is not working the way it should work. So we have a short on this board, and then you see up until now we did not connect power to the board, which is also a good thing, because the fact that we have a short on the board, that tells us that the board is not in a state to receive more power. So imagine if we had connected power to it, and then what would happen is whenever it's shorted, will obviously we will exacerbate the circuitry that is damaged on the board. So what we're not going to do is we're going to take out our screws, and we are going to hope that the issue is not NAND related, because the 16 inches, they are very common. They commonly have NAND failures. NAND failures, I'm talking about the SSDs. The 16 inches, they commonly have SSD failures, and when that happens, that is going to that we will find that will show on the PP bus through let's see, yeah, let's see that one. Okay, so that will become evident on the PP bus line through R5630. And the reason why that is this. So so if you look at this, pin 1 of this is the main PP bus line, and then the pin 2 of it is PP bus underscore G3 G3H underscore SSD. Now this is like a bridge. Hmm? This current sensor resistor is like a bridge. Coming here, pin 1 is what is coming into the circuitry for your PP bus, and then pin 2 is going to be where it makes its way onto the SSD line. So if we for example, if we have a short on the side of the SSD, and it's something that we can see on the PP bus line with R5630 removed, what will happen is with R5630 removed, what will happen is we have effectively created a divide between pin 1 and pin 2. Because with R5630 on the board, whatever you have on pin 1 is going to be equal to pin 2 and vice versa. So if you have a short on here, for example, if you remove R5630, then the short will no longer be on pin 1. That is one of the way you can easily define if your short is coming from. That is if you do not physically see any type of damage around U9080. So let's go ahead and take the board out, and then we hope that our SSDs are still intact, because that way the client files will be saved. So to take the board out, we are going to start by using our T5 screwdriver. It's 1.2. So okay, let's start with our T5. See, this is going to be longer than the rest. You see that? It's going to be compared to the rest now. See it? So that, and also you see one here and one here, two is on the side. So that also is going to be of the same size. So the two on the sides will be of the same size compared to the ones. You see them? I don't know if you can see that. Yeah. So that, but the one that at the edges of the board, those are going to be of the same size. So I see my T5 all out. Now I'm going to need a T4. T4. So I'm going to use my T3, and because that works for me as well. Let's quickly take those out. If this is the first time you're doing this, you want to make sure that you identify the screw length, and then you also want to make sure that you know which is which, because you want to make sure you put the screws back to exactly where they belong. Okay, now we are going to use a T8 for that. Okay, our screws are out. Now we are going to disconnect our cables. If you choose to use a tool, make sure your tool is not in control. Make sure you are fully in control of your tool. Okay, I'll squeeze it out. Now you want to take the board out. Now while taking the board out, you want to be careful that you don't force the board out. Be sure to have an overview of the board. See whatever it is that is resisting the board from getting out, and you can manually take it out of the way. Okay, so that's the board. It's out. Let's put the shell on the side. Okay, so first thing first, we are going to have a general inspection of the board. So let's, without even having to look further, that's our problem. See that? Yeah, it says SSDs are popped. Yeah, so we have a blown SSD on this board. We definitely have to replace the SSDs. That's not good. Okay, so for this one, we are going to replace the SSDs. We have how many? How many? 1, 2, 3, 4, 5. Yeah, we have 5. So we are going to replace SSDs on this one. Unfortunately, client is going to lose data on this one. So what we are going to do is inform the client that, listen, you have a short that is coming from your SSD, and I'm not sure if you guys will be able to see that. So what happened was our guy here, so what I was describing, this guy here got blown up. I guess you won't be able to see it. So there is a marking here, which is because of it getting blown up, and so that did the damage. So that sent out 12.6 volts to the NAND, and then it did the damage. So what happened was U9089, for example. So what I'm trying to say is, so you see how we have a short on the board. I'm just going to show you guys something. So black probe on ground, and then red probe here. Say we have a short, correct? Now if we remove that resistor, which is the bridge that we're talking about, that resistor, this one here, now the short should be gone. Let me show you. So I'm talking about this resistor. So if we remove this resistor, what we have effectively done is we have created a divide between the SSD rail as well as the PP bus rail. So the problem is it's on this side, not on the. So the problem the problem shows itself up on the side of the PP bus because of R5630. Now with R5630 out of the rail, what you will find is there will be no more short on PP bus itself, but there will still be short on this side. I'm just gonna check that out for you guys to see what I'm trying to say. Okay, so the resistor is out. Now that the resistors are out, you see that the short will no longer be on PP bus itself. So black probe on ground and then red probe. See, the short is gone because we have effectively separated the section that is shorted from the rest of the circuitry. Now, what will now happen is from this point on, you'll have the short on this side, but there will be no short on that side, correct? But when that is back on, then the short can now, whatever is on pin 1 becomes equal to pin 2 and vice versa. Now, this guy was what died, and that's why you have, so to repair this, now a quick note I want to, just a quick note. When you're doing a repair like this one, right now you have a short, and you will not obviously have, there will be no voltage because you have a short. Whatever voltage that's supposed to be present there will go to ground. When you're replacing the NAND, to replace the NAND, we are not only going to remove the one that is blown. So the way NANDs are configured, yes, they are configured in such a way that you have um, more than one item to become one. So basically, so you have one, for example, you have 1, 2, 3, 4, 5 chipsets that are bonded to be one. So in actual language, you say that, so you program them to be one, which means if one of them fails, it means the entire lot will not function because they are functioning as one. Now, even though this is the guy here that is blown, unfortunately, we cannot just remove this and then add another. If we remove this and add another one to that, it would mean that we have two sets of NAND on the board and they will not be able to work. So because of the programming, the signatures on the SSDs, this all of this now has to go out. So this, the ones that doesn't seem to be affected, they all have to go out. Now, so we can reuse the ones that are not fully faulty, but we just cannot use them as the same set as what is going to go back here. So there are two ways I go about doing this, but the way that I do it most of the time is I get an identical board, and then I transfer the NAND chip from an identical board to this one. The process is quite it takes a while. Show you. So these are some of the ones that we have done. These are some of the ones that we kept. I mean, we don't keep most of them, but these are some of the ones that we kept. We don't keep most of them, but here these are some of the ones. So the process is quite lengthy. There's one more here. So these are some of the ones that we have done. Process is quite lengthy. So what I would do is I would just take this ones out, and then I will replace with I will take another board that has same configuration. By same configuration, I mean the same NAND arrangement, and then I'll just transfer directly. Now, after the transfer is done, the next thing I'm going to do is I'm going to use Apple Configurator 2 to restore the device in order for it to work again. You have to understand that if after the transfer is done, the device is not just going to work. You have to use Apple Configurator 2 to restore the device before the device works. Now, just something that I want to mention. Now, you see how it is that U60, U9080 failed. So U9080 was what failed initially before it basically then damaged the NAND on the other side. When you are going through this process, what you want to do. What was that? Has it been here before? Do you want to just go check? So you remember that what failed was U9080. U9080 took a high voltage instead of when it failed, it stops converting the high voltage into stepping it down to a low voltage for 2.5. It rather sent out 12.6 volt to your NAND, which killed the NAND. Now, when you are doing the replacement, the process should be, I'm not gonna we are not gonna the video is gonna be too long for us to record the process. So but I'm just gonna walk you guys through how you go about it. So the NAND chip, after the NAND chips are taken out, the next thing you want to do is to address U9080. Hmm? After you, so you address U9080, so you replace U9080. Make sure you have your 2.5 volt on your output of U9080 before you install the NANDs. Do you understand? I mean, do not before you install the NANDs, make sure you have 2.5 volt. That way, for example, if you happen to have installed U9080 incorrectly, or if for some reason you see U9080 is not doing its job, then it will not send out 12.6 volt, which will then again damage the NANDs that you have just replaced. So what you want to do is, before you replace the NANDs, after the NANDs are all taken out, make sure the U9080 is addressed. You replace it, you test it to see that you have 2.5 volt and it's stable. 2.5 volt stable. Uh, 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 even though it's 2.5 volt and it's stable at 2.5 volt, then you can go ahead and install the NAND. So for this one now, we are going to inform the client that, okay, this is the state of the device. We have to uh, install the NANDs, and yeah, and we wait for them to give us a go ahead. I suppose they will give us a go ahead, but I think the most important thing is for them to know that there will be no data after the repair. Okay, so what we'll probably also make like a short video after the installations is done. Yeah, we'll see how it goes. But first, we will inform the client and then we'll take it from there. See you guys later. Okay, so this is the board that we are going to use for the SSD transfers. So what I have done is I have numbered the SSDs so that because we are going to do I remember I said we are going to do a direct transfer from this board here onto this board, and the reason and another thing you want to notice here is, you see the SSD setup are exactly the same thing on the donor board that we're using. If you look at this, and if you look at this wing here, you have that wing, that's what's going to go there, and then the other side, you see that the other side is empty. You see the other side, is empty, and also the donor board, the other side is empty. So because so if I'm just going to quickly flip it around as well. That's the donor board, and that's the board that we need. So look at that side as well. You see that this is empty, that is populated, that is empty, and that is populated. And then on this side, both are populated. See, that is populated, that is populated. And in our donor board, you have 91 as well as 94. So the reason why I numbered them is this. So I'm just going to show you guys something. So by the time you take the SSDs out, they will look like this. You will not be able to tell which is which, and you want especially when it comes to direct transfer, and given that the SSDs themselves, they are programmed, for lack of a better word, they are programmed or to function in a particular order. So you want to make sure you number them so that you don't make mistakes. So you see, I mean, this is what happens after you take them out. So you're not able to tell. These are some of the ones we had replaced. You're not able to tell which is which. So what you want to do is you want to make sure that you number the SSDs before you take them out. And then the way you number them obviously is, you see here I say 86. So that is going to be, so I'm going to show you guys now. This is our board view. Now on our board view, say you see where it says where it says U8600, I just number it 86. So the other one that says U90, U8900, for example, that is not populated, so I did not worry about that. And then if you go to the other side, see where it says U9100, U9100. So I just number them 91. I just mark 91, and then the one that says U9400, I just number it 94. Okay, and then on the other side, let's flip the board to the other side. On the other side, where it says U9200, I just number it 90. I just number it 92, and then the one that says U9300, I just number it 93. Now that way I know what goes where. And then as you know, that this other side, U87 and U88 is not populated, just on the board here. So if I flip the board to the other side, so this is going to be U88 and then U87. So what I do is I just basically use numbers 90, 93, 92, yeah, to make it easy. So what I'm now going to do is we are now going to, first of all, we are going to remove the faulty ones. We're going to remove the faulty ones. And then after we remove the faulty ones, remember we have a short on our 2.5 volt line. So what we want to do, because obviously because of this guy, and remember what happened exactly was U9800, U9800, this guy here, U9800 failed. I'm not sure if you guys can see that. I think you might be able to see that. If you see this side, you have a bit of like, you see that looks like a bounty mark. I'm not sure if you guys are able to see that. Okay, so that is the guy that failed. So what we want to do after we remove the SSDs that have failed, we want to make sure that we have 2.5 volt on that line. So we are going to install another U9800 U9080. Just gonna quickly go to that U9080. Okay, so we are going to install another U9080 to make sure that we have our 2.5 volt. Okay, 2.5 volt. We make sure that we have our 2.5 volt ready and okay before we transfer the SSD. So what we want to do now is first and first, and obviously the reason why I'm not we are not documenting the whole process, which is the removal as well as the transfer. It's because of the amount of time that it takes. So we have to remove the SSDs, and then we have to prepare the SSDs that we took out. By preparing is basically to remove the epoxy, the underfills under the chip, and then afterwards we clean the solder pads where the SSD are going to feed back. And then after the process is done, then we need to also then restore. We need to restore the board using a DFU mode. So the process is quite lengthy, so I'm trying to kind of cut down the process, cut down the video so that it doesn't become boring for you guys. Okay, so we are now going to quickly do the process of removing the SSDs and then making sure, and then we are going to replace our U9080, make sure we have 2.5 volt, then we will go ahead and replace the SSDs. Okay, so these are the faulty ones. We have taken out the faulty ones, and these are the replacement ones. So these are the replacement ones. Those are the five. These are the replacement ones. We also did like a manual reballing to get the chipsets ready. So and then another thing we have also done is we've also replaced our U9080. Is our U9080 that guy? We have replaced our U9080, and we confirmed that we have 2.5 volt. So we're getting 2.5 volt now on the output. So the next thing we are going to do now is we are going to now put the chipsets back, and we hope it works. Bismillah. So we are going to put the chipsets back, and then afterwards we will put the board in the shell and then hook it up on DFU and try to restore it. So one of the ways you can actually hope that you did a good job. It's when you hook it up on your DFU mode, it should pop up. It should already be booted into recovery, so you should find the board in recovery on your DFU mode. So that's really sometimes one of the good ways to find that the device is actually you actually succeeded. So what you now want to do while it's in recovery, it's you now want to force it off to be in DFU mode. So I'm going to quickly transfer the chipsets on the board and hope it works. Okay, let's do that quickly. Okay, so we have replaced the CD3215s. So you see the markings 92, 93. And that is one marked 86. That's 94, and that's 91. And this is our donor board where we took the chips out from. That's our donor board. That's our donor board where we took the chips out from. And these are the faulty chips. So these are the faulty chips. So what we're now going to do is we're now going to put a board in the shell and hope it works. Okay. Okay, we have now put the board in the shell, and I'm actually doing this all by myself. Shahid isn't in, being a Sunday. So the board is in the shell. The next thing we want to do is we want to hook the board up to our DFU, which is the guy. It's open. So we are going to use Apple Configurator 2 to see if the device will restore. So let's okay, so we have a cable that's going to run from our machine. That's the cable. And so depending on what device you have, that will determine which port you use for your DFU communication. So because this is an Intel, we are going to use the second port. So we're going to use the second port for Intel. The second port is so it's going to be this guy here, the second port. Now, if this was an M1, we were going to use the first port. So because it's Intel, we're going to use the second port. So let's connect it. It's connected. Doesn't seem to be detected. Okay. Now let's. Okay, that's good. It just popped up. Let's accept. Okay, so it seemed to be in recovery. That's good. So what I'm going to do is I'm going to connect charger to the machine itself. So I'm just gonna put this in DFU mode. I've only got one hand, so I'm just gonna pause the video and then put it in DFU mode. Okay, so we have so we put it in DFU mode. So right now, what you are going to do is we are going to try to restore it. So let's do that. So we are gonna say right click and then we click on restore. And then you say yes. Okay, so let's give it some time to download. Okay, so it's going to download, so hopefully it's not going to take so long. Let's give it time to download. Now, what if you have let's say if I had previously done this, for example, if I have just done that, so it will, if I had done a similar machine, it will download the file that is downloading now. And if I if I then put up a follow-up machine, it wouldn't have to re-download. It will just pull up the file that it had previously downloaded, and it will use that file. But because but as you see now, it's actually downloading the file from scratch. So let's and the process is quite fast. So let's hope. So what it's going to do first is going to download the file, and then it's going to unzip the file, and then it's going to then install. So we are really hoping that it works. So another thing is, it's not at the time when I connected the device to my machine, and then there was a pop-up. So that it's one of the benefits if you're using an M series. I'm using a 14 inches M1. So that's one of the benefit. If you're using an Intel device, you might not get that pop-up on the screen like the one that I got. So one of the benefits of using an M series, it's you get a pop-up when an external device is trying to communicate, especially in the case of trying to restore your machine through DFU mode. So we just giving it a so now the SSDs that we transferred, there was no way we could confirm that the SSDs are working. So we're just hoping that Allah makes it that the SSDs that we transferred are going to work, because it's a lot of work, and also which is one of the reasons why I could not have like a straight video uh, to put you guys, I mean to take you guys through the process. It takes a whole, I mean, it's so much of work involved. So um, there's so much of work involved. So for that reason, I tend to kind of not take you guys through the entire installation process. Okay. And then another thing is also with the so I will also be responding to the prompt of the machine. So hopefully now it's unzipping and now it's installing. So I'm really hoping that it works. I pray and hope that it works. So let's accept that. We get a prompt. Let's accept the prompt. Allow. We're hoping to get another prompt if it works. Alhamdulillah, that's still good. It's another prompt. Let's hope that it doesn't fail. Allah make it that it doesn't fail. I'm really hoping that it doesn't fail. It's a lot of work. I hope it doesn't fail. Uh, that's not so good. We It's not good. So what we're seeing is yeah, it's not so good. Looks like there was like a brief disconnection and then a reconnection. That's not so good. Hmm, that's not so good. Hmm. Okay, so if it doesn't work, we may have to two things. Number one, it's we may have to check to be sure that the SSDs are actually fully installed, and also that none of the SSD chips are faulty. And so we will have to go over. Nah, that's not good. Error 9. So usually, okay, but this time it says something about the operation could be completed. Error 9 failed to receive message from device, might be connection problem with USB host. Okay, so let us change the cable. Let's get another cable. I'm just gonna so let's get another cable. By the way, when it comes to the ports to connect the USB-C cable to on the host, you can connect it to any port. It doesn't matter. But when it comes to the machine itself, it's what matters the port that you use. So we're gonna put it back on the second port. Okay, so click on OK and try the process again. It's a recovery, so I'm gonna again force it into DFU. Okay, so we put it in DFU mode. So right now what you are going to do is we are going to try to restore it. So let's do that. So we are gonna say right click and then we click on restore and then we say yes. Okay, so let's give it some time to download. If okay, so it's going to download, so hopefully it's not going to take so long. Let's give it time to download. Now what if you have let's say if I had previously done this, for example, if I have just done that, so it will, if I had done a similar machine, it will download the file that is downloading now, and if I follow, I mean if I then put up a follow-up machine, it wouldn't have to re-download. It would just pull up the file that it had previously downloaded, and it will use that file. But because but as you see now, it's actually downloading the file from scratch. So let's and the process is quite fast. So let's hope. So what it's going to do first is going to download the file, and then it's going to unzip the file, and then it's going to then install. So we are really hoping that it works. So another thing is, you saw the other time when I connected the device to my machine, and then there was a pop-up. So that it's one of the benefits if you're using an M series. I'm using a 14 inches M1. So that's one of the benefits. If you're using an Intel device, you might not get that pop-up on the screen like the one that I got. So one of the benefits of using an M series, it's you get a pop-up when an external device is trying to communicate, especially in the case of trying to restore your machine through DFU mode. So we're just giving it a, so now the SSDs that we transferred, there was no way we could confirm that the SSDs are working. So we're just hoping that Allah makes it that the SSDs that we transferred are going to work, because it's a lot of work. And also, which is one of the reasons why I could not have like a straight video uh, to put you guys, I mean, to take you guys through the process. It takes a whole, I mean, it's so much of work involved. So um, there's so much of work involved. So for that reason, I tend to kind of not take you guys through the entire installation process. Okay. And then another thing is also with the, so I will also be responding to the prompt of the machine. So hopefully now it's unzipping and now it's installing. So I'm really hoping that it works. I pray and hope that it works. So let's accept that. We get a prompt. Let's accept the prompt. Allow. We're hoping to get another prompt. If it works, Alhamdulillah, that's still good. It's another prompt. Let's hope that it doesn't fail. Allah make it that it doesn't fail. I'm really hoping that it doesn't fail. It's a lot of work. I hope it doesn't fail. That's not so good. We It's not good. So what we saying is yeah, it's not so good. Looks like there was like a brief disconnection and then the reconnection. That's not so good. Hmm, that's not so good. Hmm. Okay, so if it doesn't work, we may have to two things. Number one, it's we may have to check to be sure that the SSDs are actually fully installed, and also that none of the SSD chips are faulty. And so we will have to go over. Nah, that's not good. Error 9. So usually, okay, but this time it says something about the revision could be completed. Error 9 failed to receive message from device, might be connection problem with USB host. Okay, so let us change the cable. Let's get another cable. I'm just gonna so let's get another cable. By the way, when it comes to the ports to connect the USB-C cable to on the host, you can connect it to any port. It doesn't matter. But when it comes to the machine itself, it's what matters the port that you use. So we're gonna put it back on the second port. Okay, let's click on OK and try the process again. It's a recovery, so I'm gonna again force it into DFU. Okay, so we put it in DFU mode. So right now what we are going to do is we are going to try to restore it. So let's do that. So we are gonna say right click and then we click on restore and then we say yes. Okay, so let's give it some time to download. If okay, so it's going to download, so hopefully it's not going to take so long. Let's give it time to download. Now what if you have let's say if I had previously done this, for example, if I have just done that, so it will, if I had done a similar machine, it will download the file that is downloading now, and if I follow, I mean, if I then put up a follow-up machine, it wouldn't have to re-download. It will just pull up the file that it had previously downloaded, and it will use that file. But because but as you see now, it's actually downloading the file from scratch. So let's and the process is quite fast. So let's hope. So what it's going to do first is going to download the file, and then it's going to unzip the file, and then it's going to then install. So we are really hoping that it works. So another thing is, it's not at the time when I connected the device to my machine, and then there was a pop-up. So that it's one of the benefits if you're using an M series. I'm using a 14 inches M1. So that's one of the benefit. If you're using an Intel device, you might not get that pop-up on the screen like the one that I got. So one of the benefits of using an M series, it's you get a pop-up when an external device is trying to communicate, especially in the case of trying to restore your machine through DFU mode. So we're just giving it a, so now the SSDs that we transferred, there was no way we could confirm that the SSDs are working. So we're just hoping that Allah makes it that the SSDs that we transferred are going to work, because it's a lot of work. And also, which is one of the reasons why I could not have like a straight video uh, to put you guys, I mean, to take you guys through the process. It takes a whole, I mean, it's so much of work involved. So um, there's so much of work involved. So for that reason, I tend to kind of not take you guys through the entire installation process. And then another thing is also with the so I will also be responding to the prompt of the machine. So hopefully now it's unzipping and now it's installing. So I'm really hoping that it works. I pray and hope that it works. So let's accept that. We get a prompt. Let's accept the prompt. Allow. We're hoping to get another prompt. If it works, Alhamdulillah, that's still good. It's another prompt. Let's hope that it doesn't fail. Allah make it that it doesn't fail. I'm really hoping that it doesn't fail. It's a lot of work. I hope it doesn't fail. That's not so good. We It's not good. So what we're seeing is yeah, it's not so good. Looks like there was like a brief disconnection and then a reconnection. That's not so good. Hmm, that's not so good. Hmm. Okay, so if it doesn't work, we may have to two things. Number one, it's we may have to check to be sure that the SSDs are actually fully installed, and also that none of the SSD chips are faulty. And so we will have to go over. Nah, that's not good. Error 9. So usually, okay, but this time it says something about the revision could be completed. Error 9 failed to receive message from device, might be connection problem with USB host. Okay, so let us change the cable. Let's get another cable. I'm just gonna so let's get another cable. By the way, when it comes to the ports to connect the USB-C cable to on the host, you can connect it to any port. It doesn't matter. But when it comes to the machine itself, it's what matters the port that you use. So we're gonna put it back on the second port. Okay, let's click on OK and try the process again. It's a recovery, so I'm gonna again force it into DFU. Okay, so we force it back into DFU mode. We have changed the cable. Let's start the process again, and let's hope that it works. We right click, and then we say restore. So hopefully this time it's not going to go over downloading again because it's already downloaded. So it's just going to, yeah, so it's not downloading, it's just installing. Mm. We hope just hoping that Allah makes it easy, that it works. Allahu Akbar. Alhamdulillah. 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 Alhamdulillah Rabbil Alamin. Okay, guys, that's your beautiful Apple logo. I'm super happy because there's so much uncertainty when it comes to this job. You're not, there's no way you can confirm that the USB, that the SSDs that you've used are actually okay. There's no way to confirm that, okay, probably one of the SSDs might not have been properly installed, but Alhamdulillah, sometimes we have to do it multiple times for it to work. But Alhamdulillah, this time it was one time, and Alhamdulillah, that's a beautiful Apple logo. That is a beautiful Apple logo. So the next thing is we are now going to clean the board properly and then reinstall operating system on the device. Alhamdulillah, I'm super happy with this one. Thank you guys. Yeah. I will see you guys in the next one. So, yes, that is a device that powers on. This was the device that the SSD got burnt out. So, what we had to do was first we had to identify the issue. We identified the issue to be a short on the PP bus, which was caused by U9080. U9080 failed, and then it damaged U8600, which is one of the USB-C, one of the SSD, and then so we then have to remove we had to remove the entire SSDs, and then we had to get a donor board that has the exact SSD setup to match, because we had to do a direct transfer without having to reprogram the SSDs. And we followed up with the process, and after that we obviously then had to go through the restore process. The first time failed because the cable was giving us issue, and that is it. That's a beautiful lock sign. So whenever you see the lock sign, it's basically will tell you that the device is booted. So if we click on that, see what it says. It says device is booted. So I can just force the device. I can just force it down, shut it down completely. You look, as I'm holding the power button. Okay, it's off. So I'm going to power it back on again. So I'm going to power it back on again. Alhamdulillah, this is very beautiful. So I powered it back on again. So we should see it, and so yeah, that's and on my secondary on my machine, I see that the device is booted. So I'm just gonna wait for it to start on the primary machine itself. So sometimes it takes a bit of a while, but only that's going to be like the first time in terms of, yeah, alhamdulillah, that's it. That's your Apple logo. So we now going to, that's a beautiful flashing folder. So we are now going to clean the board and then restore the operating system, and that's it. Thank you guys. I will see you guys in the next one.